Well, let's now look at Chapter 9, t-tests, and let's take a look at Chapter 9, Problem 9. And if we look at the problem, okay, it says to evaluate the effect of a treatment, a sample is obtained from a population with a mean of 75. And the treatment is administered to individuals in the sample. After treatment, the sample mean is found to be 79.6 with a standard deviation of 12. So for A, if the sample consists of n equals 16 individuals, are the data sufficient to conclude that the treatment has a significant effect using a two-tailed test with an alpha of 0.05? So let's take a look at that. And so the facts that we know. Okay, so we're doing part A of number 9. Okay, so it's number 9. And we're doing A. That looks purely awful, so let's get rid of that. Okay, so here's 9A. Okay, so for that, n equals 16. The mu is 75. Standard deviation equals 12. And the mean for this sample is 79.6. Now, this is supposed to be a two-tabled test, and so the alpha for this for this test is 0.05, which means that this is going to be split between these two tails. This is 0.025, and over here is 0.025 in that tail. We're going to, at this point, we'll look at the null hypothesis. And so the null hypothesis is going to state that mu is equal to 75, and the alternative hypothesis, mu will not equal 75. And we use that terminology because it's a two-tailed test. We're going to need to know the degrees of freedom to find out the t-critical on this. So we'll start off with that. So df equals n minus 1, and that means that that is going to equal 15. And it's 16. 16 minus 1 is 15. So now what we're going to do, see, we've got the alpha right there, and we've got the degrees of freedom, and now we're going to go to the t-test table, which is in the back of the book on page 589. Now we look at the degrees of freedom, Okay, degrees of freedom is 15. And we look in the two-tailed combined part of the table. We slide on down until we get to 15. And we've got a T critical that's going to be T critical equals 2.131. Okay, so let's come on over here. T equals the mean minus the population mean, mu, and the standard deviation, or SM, and that equals well, we got to find out what SM is first, right? Okay, so let's do that. SM equals standard deviation of the mean over the square root of n. That equals 12 from right up here over the square root of 16. That equals 12 over 4. 12 divided by 4 is 3. Okay, so we're going to go right up here. And so M is 79.6 minus 75 over 3. And that's going to be 4.6 divided by 3. And that will equal 1.53. We can now notice that 1.53 is less than our T critical value of 2.131, and we will now reject our null hypothesis. Now in in 9, part B, essentially it's the same problem, except you'll notice that the sample size is 36, and so we have the same two-tailed test. The alpha is still 0.05. First thing we need to do is to look at the degrees of freedom. TF equals n minus 1, so that equals 35. So the degrees of freedom are 35. Okay, now we need to go look in our table. Okay, so we have degrees of freedom is 35. Okay, notice we got a 30 and a 40. We come over here to the two-tailed test with 0.05, and so 30, between 30 and 40, so we can see that between 2.04 and 2.03, we should call that a 2.03. So that will be our T critical. So RT critical is 2.03. Okay, so we'll come over here. T equals m minus mu divided by S sub m. All right, so first we need to calculate SM equals the standard deviation of the sample over the square root of n. Okay, the standard deviation is 12. The sample is 36. Okay, that equals 12 over 6, which equals 2. We come back over here. And we take a look at this. The mean is 79.6, and mu is 75. And that is over 2. Let's see, that is 4.6 over 2 equals 2.3. Okay, now let's compare that to our RT critical. So 2.3 is greater than 2.03, and so we reject our null hypothesis.